Let's get really excited about unit testing. All right. All right, so about me before we get started. I am a senior UI engineer at Netflix. If you have any questions about this talk or want to talk to me about anything JavaScript related, or have some questions about unit testing, please feel free to reach out to me. My email is ryan.anklam@gmail.com, and I'm also on Twitter, Bittersweet Ryan. Talk mostly about JavaScript, and I would love to talk to all of you about it. So we're going to talk about a few things today. The first thing is adding testing to your project. Then we'll talk about solving some common testing issues. And then here I have writing testable JavaScript bolded and kind of washed out on the blue. But I think this is probably one of the most important aspects, right? A lot of JavaScript that's written, especially for the client, is not written in a testable manner. So we're going to talk about how to write code that's easy to test, that doesn't make testing a pain in the butt. And then lastly, we'll just talk about automating testing, because removing barriers to testing is also a very important part to unit testing. So the first thing I want to talk about is adding testing to your project. And this might not seem like a very important thing, but when you think about it, it really is almost one of the most important parts, because the decisions you make at this point are actually going to have to live with this project throughout its life cycle. Right? You want to pick your unit testing framework as carefully as you're going to pick an MVC framework, right? You want to pick Ember, Angular, or React. You want to make that same kind of decision with your unit testing framework. So the first thing you want to do is think about the environment you want to test your code in. Right? So you're going to test your code in Node. Here's a few of the popular frameworks in Node. Not an extensive list, but Mocha, Jasmine, Tape, and Jest. So Mocha is probably the one you'll see the most. It's probably one of the most popular right now. It was written with Node in mind first, where a unit testing framework like Jasmine was actually written for the browser first and then made to work in Node. There's also one down here I have called Tape. And what's nice about Tape is it'll let you allow to write your unit tests and actually run your unit tests without having to invoke a test harness. So if you had Mocha test, you'd have to run the Mocha command and then run your tests through Mocha, but Tape will let you just test a JavaScript file. And then Jest also is a brand new one. It's actually a layer on top of Jasmine. It was written by the folks at Facebook when they were writing React. So I don't have a lot of experience with it because it is very, very new, but I am excited about it. It does things like it will actually automatically mock a lot of your component or your requires if it sees them. So it gives you some nice stuff right out of the box. If you're using the browser, again, a lot of the same options here. But it's kind of flipped a little bit because Jasmine is a little bit more popular in the browser space. It was written for the browser first and kind of made to work in Node. But at work we use Mocha for everything because we do test in Node and in the browser. So we want to have one single testing framework that works equally well with both of them. So Mocha is the choice we used. And also QUnit. I think QUnit is kind of like the underdog testing framework. It doesn't get mentioned as much as some of these other ones now. But if you're just starting with unit testing, QUnit has the least friction to actually get started with testing. So if you want to get started, QUnit is a really good place to start. And then if you feel like you're outgrowing QUnit, you can look into one of these other ones like Mocha or Jasmine. So the next thing, once you get your testing framework picked out, you have another decision to make. You need to pick your testing dialect. So what kind of verbs are you going to use to write your test? So the first thing I want to talk about is the expect syntax. And it's common in behavior-driven development. So here's a simple test written with an expect syntax. So the first thing you can see is that our entire test is wrapped in this describe function. And then the next thing inside of our describe function is an it function. So that's kind of a way to break up the tests. The describe is like the outer wrapper that's going to test our, we're going to wrap all our functions test in there. And then the its are going to be the individual tests for that particular function in this case. And if you notice, the string in the describe statement, when added to the string in the it statement, is actually going to form a sentence. And that's nice because the output of your tests then are going to be readable and you're going to kind of know what's going on. And then inside of our it is our actual assertion here. So here we're going to say expect. We're going to invoke adder, so the result of adder, to equal 0. So the next grammar is going to be a should, and it is extremely similar. If I go back to the left side, you'll see that only the order of where our assertion is kind of changes, right? So now we have adder, and we're going to invoke that function, and then we're going to attach the should to it, and then we'll say it should equal 0. So it's a very small difference, but maybe it is important to someone. So the last kind of grammar I want to talk about is assert. And this is kind of more traditional unit testing style assertions. So the first one is a QUnit example test. And QUnit is going to wrap its tests in a test function. So we're just going to say test, then we'll pass in that adder. And then we're just going to have a little bit more imperative type of test. We're going to say test, make sure adder equals 0. So we're actually going to imperatively say what we're trying to test and what it should equal. And then we're going to just say that should return true, or that should be truthy, and that if it fails, we should say it should return 0. And if we're going to use Mocha and Chai together to create assertion style tests, we're going to use that same describe syntax, and we're going to say assert.equals, and we're just going to pass in our function invocation. So whatever value we're trying to test is the first argument, the expected value is the second argument, and then the what we're going to say if it fails as the third argument. So you've got your testing framework picked out, you know what dialect you want to use, now you just got to add it to your project. So if you're using Node, process is simple. We're going to first install the Mocha, and in this case we're going to install the Mocha framework globally. So it's going to let us run the Mocha command from any test or any project we want. Then we're actually going to install NPM as a local dependency on our project. And this part is actually important and overlooked a lot. And the reason we want to do this is because if we're going to install the test command in our npm package.json, the Mocha framework is actually inside of our project as a local dependency. So then our continuous integration server doesn't actually have to have Mocha installed as a global dependency. It can just run it and run your tests right there as it's getting built. Then the third one here we have npm install Chai because we're using Mocha. So we do need an assertion library on top of that. So here is an example function we're going to test. It's a function just called adder that has a little bit of a syntax error on top. And we're going to just pass in some arguments. We're going to reduce over them to create a summation function. Now how we're going to test it is we're going to first import or require our assertion or expectation library. So we're going to say require chai.expect. So we're using an expectation style syntax. Then we're actually going to include our source file. Then we're going to actually test that function down here. We're going to say describe the adder function. And we'll say it should add an array of numbers. And then we'll do expect adder. We'll pass it in 3 different integers, and we expect that to equal 6. And then we're going to make a little bit more of a robust test here. We're going to, just testing three integers isn't going to cover all of our situations. So we're going to also make another test. We're going to say, we want this to equal 0 when we invoke adder with no arguments. And we're also going to make sure that if we add non-numbers, that adder is going to return the value we expect as well. So here we'd expect this to equal 3. That might be a little bit, oh, it shows up okay. So here we're going to say expect adder 1, 2, and a to equal 3. So we'll expect this function to skip that string. If we wanted to go even farther, we would just test passing in a single string, passing in a single integer, things like that. And to run these tests, we're just going to run the Mocha command. So we're going to say Mocha, and then we're going to pass it an argument or a path to our specs directory. So this is going to actually go ahead and pick up all of our specs inside of that directory and run them. And when you do that, you're going to get a similar output to your console. I was going to show a live demo, but I don't want to tempt my machine's god Ziggin to come out and crash my machine. So this is what it would look like. Here I put a bug in the code just so you'd see what it looked like if we have a failing test. So here we have 2 passing tests and 1 failing test. And you can see that we actually get that the combination of our describe and our it function down here. So here we say adder should skip non-numbers. And then we get a nice little stack trace so we can go back to our code and start debugging it. So if you're testing in the browser, it's pretty easy. So the first thing we have to do is create our spec runner file, or our runner HTML file. So in this case, this is actually a Jasmine test, whereas the previous one was using Mocha. And the nice thing about Jasmine is it comes prepackaged with this spec-runner.html file. So all you have to do is change the links to their source files and their spec files, and you'll be able to get up and running real quickly with unit tests. So the first thing you're going to do is actually include your source files in a script tag, just like you would a regular website. And then you're going to include your spec files as well. And that's all you really have to do. And then you can open up this file in the browser, and it will run your specs. So here's the same output we had with that in the console before, but this is what it looks like with Jasmine in the browser. And what's kind of nice about Jasmine in the browser is you can actually click on that failing test, and Jasmine will only run that particular test. So what we do at Netflix is we actually include this in our QA environment, so the QA engineers can go in and run the unit tests through a browser, so they don't have to open up a terminal or anything. So, a lot of you probably don't have code that looks anything like adder function, right? It's a simple function, there's no side effects, it doesn't call anything else. It's really simple and really easy to test. And unfortunately, in the real world, nothing is quite that simple. So let's talk about solving some of those common testing issues that you might run into. So the first thing that you run into pretty quickly is that you have methods that go out and call other methods or functions. And when you're doing unit testing, you want to make sure that your unit test is pure. You want to make sure that it only tests that individual function and doesn't rely on the code from another function that can change it. So when you have functions that call other methods, you want to make sure that you have a way to replace those calls with something. And that's where Spies, stubs, and mocks come in. So we're talking about Spies. We're not talking about the NSA. This isn't Prism. We're actually going to use frameworks to do some of that for us. So Jasmine comes packaged with a nice spying library, or spying functions in it. And there's also a third-party library called signon.js that does a lot of spying, mocking, and stubbing for you. It's actually a little bit more powerful than that. It'll actually do fake XML AJAX requests. It'll do a fake timer, so if you're relying on things for timing, you can actually fast forward ahead the clock and not have to wait for that stuff. And then since Jest is built on top of Jasmine, it also comes with spying and stubbing and mocking. So in this example, we're just going to use Jasmine, and Jasmine uses the spy word for everything. So here is a simple function. It's just going to be add user, and we're going to check if a user is valid first, and if a user is valid, we'll save them. Otherwise, we're going to call add error. So really not a lot of stuff going on here, but we do want to make sure this thing works as planned. So here we have this function is going to call potentially call three other functions outside of it. It might call validate. It's always going to call validate user. Sometimes it might call save user, and sometimes it might call add error. So this is a little bit of how our test is going to look like to test that code and not have to worry about those other functions. So we're going to say it should save a valid user. So in this case, we want to make sure that our user is valid. So what we're going to do is say spy on the user object and the validate function. And when that function's called, always return the value true. So we're going to say spy on user, return true whenever it's invoked. And they're also going to spy on the save function, because if a user is true, we expect save to be called. And here down in our assertions, we're going to say expect user.validate to have been called and expect user.save to have been called. So this test now is going to cover our happy path, our save path of a valid user. But we do have to make sure that we are creating a robust enough test, so we're going to make sure that we save a user that is not valid. So we're going to return false here in our spy. So we're going to say spy on user.validate and return false. And then we're going to change our other spy to spy on the add error function. So now we're going to say expect user.validate to have been called again, and say expect user.addError to have been called. So if you have a function that expects data to be returned from it, right? That previous example was just invoking different functions. So here we have a function called listusers, and the first thing it's going to do is call this.getUsers. That's going to return an array of users, and then it'll just iterate over those users and call another function with those users. So here, we're going to want to spy on the getUsers function and make sure that it returns some valid data. And again, in a unit testing scenario, we want to have strict control over that data. We want to know what that data is. So now we're going to create another test with a spy on user, and we're going to tell it to return a value. So here we're going to say return an array of user objects. And then again, we'll spy on the add user to list function, and then we're just going to expect those functions to have been called. Now, because I don't have a ton of room on these slides, you can actually go a lot farther with this. You can make sure that a function's called with particular arguments or called a number of times. And I have a few examples of that a little bit later on. So who uses promises right now? Awesome. So promises are a pain in the butt to test because everything's trapped in callbacks, right? Fortunately, there is a really simple way to do that. So here's some code that is actually going to return a promise. It's when it does that, if it finds this, it's going to resolve that promise and pass in a string value into the resolve to your then function or then callback. So here we're just going to say describe getStringValue function, and we're going to use a framework called a chai as promised. So it's actually a part of the chai testing framework, but if you use this, it makes testing promises extremely easy. So if you look down here in our first assertion, we're going to say expect utils.getStringValue to eventually equal foobar baz. And what that to eventually equal is going to do is it's going to go ahead and listen to the then callback or override it, and then whatever function's passed into the then function, it's going to make an assertion against that. So here we expect that foobar baz will get passed into our then callback. And one thing to point out here is that we actually have to return a value here. If we don't return the value, your test runner is going to hang because it's never getting anything. It's not going to actually return. It's just going to keep waiting for that promise to be resolved. So if we return it when that promise is resolved, the next test is going to run. So the next common thing people run into a lot is testing the DOM. Right? You have this jQuery that does a whole lot of things. It appends things. It removes things. It does a lot of things. And here I'll ask the question, do you really need to test the DOM? Because using spies, mocks, and stubs like we talked about before, we can actually just spy on DOM functions and make sure that our code is doing what we want it to do to the DOM. So jQuery makes this extremely easy, but you can spy on document.query selector or append a child, things like that. So here's a simple function that's called AddItems. It's going to take an element and a list of items and just try to append them all to that element. And now we're just going to spy on jQuery and to make sure that those things are actually done. So here we're going to say, we're going to create a fake element, a fake list of items, and then we're going to say spy on the jQuery.function namespace and spy on the append function. So here we're just going to call AddItems. We'll pass in our fake element, pass in an array. Then we're going to say expect jQuery.function.append to have been called. So now we're actually making sure that we're trying to do something to the DOM without actually needing a DOM. But there are some cases where you legitimately need a DOM. If you're creating jQuery plugins or something like that, you want to be extra sure. So there's a couple libraries that help you. The first one is Jasmine jQuery. And what this will actually do is give you the ability to add fixtures to your test files. So you're going to create a fixture which is .html file that has the HTML you want to test. And then it'll actually inject that fixture into each test, so making that DOM available for each and every test, and it'll get reset after every test. And then it gives you another, a nice addition of assertions. So you have other, more assertion methods to call that are specific to the DOM. So you can say like to have class or to exist, things like that. So here's a real simple example. So what we're going to do is in our before each test hook. So before each is a special function that'll get run before each and every test. So here we're just going to say load fixtures, and we're going to pass it path to an HTML file. So in this case, my fixture will be loaded and injected into each and every test. And then we're just going to say it should convert a select to a UI. So we're just creating a drop, a fake drop down. And then we're going to invoke our function here. We're going to say on a select item called dropdown. And then we're going to say expect this item to exist on the DOM. So we'll say expect.selectList to exist inside of our fixture after that function is called. Now again, QUnit makes this even easier. QUnit actually has a div called QUnit fixture that's going to take whatever HTML is inside of there and inject it into every test and automatically reset it after every test. So there's a lot less setup, a lot less work you have to do to get this working in QUnit. So again, that gets reset after every single test. You don't have to worry about artifacts from a test being left behind for the next test. So another big problem you run into when you're trying to unit test is you're testing async code. And when async code fails in a unit test, it is absolutely maddening, right? Because it's asynchronous, depending on how fast your unit tests run, sometimes a test will pass, sometimes a test will fail, and you don't know what the heck's going on. Fortunately, testing frameworks have gotten a lot better at dealing with this, especially Jasmine 2.0 fixed a lot of things that I didn't like about their 1.0 release in async testing. So here's just a simple test. We're just going to have a function called readConfig. That's going to call fs.readFile. It's going to take a file location and invoke a callback function. And to test this function, what we're going to do is create another function called callback. Actually, let me back up a second. So inside of our it callback function, you'll see now that we have an argument called done. And Mocha, in this case, is actually going to see that argument and know that argument's passed in and wait for done to be invoked before it calls the next test. So what we're going to do is create that callback function that gets passed into readConfig. And then we're going to make an assertion in there. So the ready state will get passed into this callback. And then we're just going to say expect that to equal config ready. And then next thing we're going to do is actually invoke that done callback. So that tells Mocha, in this case, that it can start running the next test now. And then we're going to invoke readConfig and pass it that callback we created as the callback. QUnit, very similar, but the difference is we're actually going to create a different kind of test here. So in my first QUnit example, we created a test using the test function. And in this case, we're going to use the async test function. So this tells QUnit to wait until that start function is invoked. So our callback is exactly the same as it was before. Instead of invoking done, we're just going to invoke start. And then that's going to tell QUnit to go ahead and run the next file. So now let's talk about how we're going to use all these things we just learned to write some testable JavaScript. So here's an example of some poorly written jQuery code. But it's probably all too common, especially in legacy code. I think we've gotten a little bit better at writing JavaScript these days. But this code is extremely untestable. First problem we have is that everything's locked inside of that jQuery callback. Right? It's going to be trapped inside that closure. We can't reach in and test individual parts of that code. We also have some magic data. This to-dos data is just going to fire off a jQuery or an AJAX request when the document's loaded, and then it's done. We can't call it again. We don't really know where it came from. We can't configure this function because our jQuery selectors are hard-coded right there. So we have strings that's hard-coded, so we want to fix that. We also have anonymous functions as callbacks. So if you're actually trying to debug code and you have anonymous functions, it's much harder to debug it because your stack traces become a lot less helpful. So it's good to break these out into other functions, separate functions, and pass them into the handler. We have a one and done function, right? This todos.forEach. It's going to run once when the DOM's ready, and that's it. If we want to add more items to this list, we got to actually write the exact same code again. So we want to make that repeatable. Another thing we do is we have this code, the exact same code repeated twice. And we want to factor that out into a single function where we don't have to keep writing that code more than once. So first let's tackle this Cant Configure problem. And the thing to do here simply is just to make this function a constructor function. So here we're going to create a new variable called todos. That's going to be a function that's going to accept two arguments, which is going to be the jQuery selector for list, or actually a jQuery object for list, and a jQuery object for import. Now we can pass in whatever we want here. If that selector changes, we don't have to change our actual implementation code, we just have to change the code that calls it. So it makes it a lot more maintainable. Other developers will like you a lot more if you write code that looks like this. So the first thing we're going to do is a little bit of setup code in our unit test, and then we're going to actually write a unit test for that constructor function. So the first thing we're going to do is create a variable called to-dos inside of our describe block, so every test will have access to it. And then in our before each function, we're just going to create a new instance of to-dos. And this makes sure that we're testing a fresh instance of to-dos in each one of our tests, so that something, an artifact of a later test isn't hanging around that will actually affect the outcome of some of our tests down the road. And the very first test we're going to write is a simple test, and it doesn't look like it actually does much, right? We're just going to say it should create an instance, and we're going to expect the type of to-dos to be an object. And what this gets you is a real quick win, because if someone writes code that actually completely breaks the object, this test is going to fail, and it'll fail quickly. And you're going to know that something's wrong. So it's just a real good sanity check, and it's a real good quick failure. So now we got that out of the way, let's fix this magic data, right? We want to be able to get this data anytime. We don't want it to run whenever the DOM's ready. We might want to control when it's called. So the way we're going to do that is just create another function. So here we're going to create a get data function on our to-dos prototype. And we're going to accept a success callback and an error callback. And at the end of that AJAX request, we're going to, and since this is an asynchronous operation, we're going to pass this function our done code. We're going to create a callback. Inside of that callback, we're going to create our assertion. So we're going to say expect items as an instance of an array to be true. And then when that assertion is made, we're going to actually invoke our done callback, which is going to tell, in this case, this is Jasmine code. It's going to tell Jasmine to move on to the next test. And then we'll actually invoke that function here and pass it the callback. And I have a note here because this test is definitely not enough to properly test our get data function, right? We want to test air conditions. We want to test if we pass it a callback that does different things. We want to do a lot more things to test this. So just want to point that out. Now the next thing we're going to tackle is a couple things at once. We're going to get a couple wins here. We're going to eliminate these anonymous functions. We're going to eliminate that one and done type deal, so we're going to be able to actually add items to a list later on, not only once when the document's ready. And we're also going to fix all this repeated code. And to do that, we're just going to break this up into two different functions. So the first function we're going to write is called AddItem, and it's just going to take a name as a string parameter, and then it's going to append that to the list. In order to test that function, we're going to do that real quick win function. We're going to say expect it to be a function. And then we're going to try to add that to the DOM. So we'll say it should try to add an item to the DOM. And we're going to use our spy on the DOM technique. So here we're going to spy on jQuery.function.append. And we're going to go ahead and invoke to-dos.addItem. And then we're going to actually make that assertion a little bit more specific in this case. So here we're going to say expect jQuery.function.append to have been called with, and then we're going to pass in a string of how we expect that function to be invoked. So if this function was invoked with anything but that exact string, it will fail. So we had that loop that added more than one item. So now we're just going to break that out into its own function. So now we're going to have an addItems function. And all we're going to do is take an array of items, loop through them, and add them to the list item using that addItem function we just created. So in order to test this, we're going to say it should have an addItems function. We'll spy on the addItem function we just created. And then we're going to call to-dos.addItems, and we're going to pass in an array of data. And here we're going to make some more specific assertions. So we're going to say expect to-dos.addItem to have been called with each and every element we passed into that addItems. So we want to make sure that everything we called in, that function did loop through it properly and made the right calls to addItem. So the next thing we're going to tackle here is this anonymous function, right? So we have an input key up listener, and we're passing in an anonymous function. So we can't, if we wanted to create this exact same listener on another object or another keystroke or something like that, we couldn't because it's locked in this anonymous callback. So we want to factor that out to make sure we can reuse that key handler in other places if we wanted to. And we want to make sure we can test it. To do that, we're going to create our candle key press function. So here we're going to say to-dos.prototype.handle key press is going to be a function that gets an event. Now what we're going to do is do the same thing we did in our jQuery on ready callback. So we'll say if E is an enter key, we're going to call AddItem, and then we're going to reset the value. So to test that code, we're going to say it should have a key press function again for that real quick and easy win. And then we're actually going to check and make sure that it handles a key press properly. So here we're going to spy on todos.addItem. And then we're going to call handle key press, and we're just going to pass in a fake event that only has the property that we're looking for. And then we're going to expect that todos.addItem was called with the value of foobar. Now that foobar value actually comes all the way back to our setup function, because when we created that setup function, we created a fake jQuery input that had a value of foobar. So we know that that's actually what should be the value of that function when enter is called. So last thing we're going to tackle here is having all this code locked in a jQuery Document Ready Callback. And to do that, it simply is creating a init function inside of our new to-dos prototype object. And then what we can do is inside of our jQuery callback, all we have to do is call todos.init. And then all that code just becomes a single line. So in init, what we're going to do is actually create our input handler, and we're going to actually call that getData to start adding items to that array. So to test that, we're going to make sure that the init method exists. And then we're going to actually make sure it has a setup handler and an addItems function. Or it should set up the handler and call addItems. So here we're going to spy on jQuery.function.on. So we're going to make sure that we called that function. And then we're also going to spy on getData because we call that function in our init function. Again, we invoke todos.init, and then we just create our assertion. So here we're just going to say expect jQuery.function.on was called, and we're also going to expect todos.getData was called with todos.addItems. That looks a little confusing, but remember our getData function expected a callback. So we're passing that addItems function as the callback there. So we're just going to make sure that that object was passed into todos.getData. So a few more tips on writing testable JavaScript. And the first one here, I can't stress this enough, is write maintainable tests. A lot of times, people treat their unit test code, write it in a very disorganized and quick fashion just to get the unit tests out of the way. But what that does is make sure, A, that the next person that comes in is mad at you when they look at unit tests. It's going to make sure that you're not writing maintainable tests. So the next person that comes in to add a new test, or if they change an API call or something, they're not going to like your tests either. So if you write maintainable tests, you're going to help create a testing culture on your team that is sustainable, and people will start to enjoy writing tests. The next thing I want to talk about is avoid using singletons. It's overall just a bad pattern, but in unit testing, it's really bad. Because, again, going back to that you don't want any artifacts of another test changing a future test. If you have a singleton, every test is going to change the internal state of that object. So you're never actually testing a pure object. The next one, again, is used named functions instead of anonymous callbacks. You get a lot of other wins here. First of all, it's more testable code, and you get code that's easier to debug too, and easier to reuse. So you get a lot of wins with using named functions instead of anonymous callbacks. The last thing is keep your functions small, right? A small function that only does a single thing is much easier to test and create assertions for than having a big long function where you got to create a bunch of mocks, a bunch of stubs, and you got to create a bunch of different assertions, test a lot of code paths. So if your functions are small, you can test them much easier, and it makes your code much more maintainable. You can use bits and pieces of that code to create other code and make it a lot easier. So last thing I want to talk about is automating testing. And that's because, again, I can't stress this enough, is that the key to creating successful unit testing is to make writing and running tests easy. It shouldn't be a chore for someone to write a unit test. They shouldn't have to write a test, go into their terminal and run a command, write a test, go into their browser and hit refresh. It should all be automated. There's a couple different ways we can do this. And the first way is to just use NPM itself. And this is really good for your continuous integration system. So it can actually use this NPM test script to run your unit tests. So here in our package.json, inside of our scripts property, we're going to create another property called test, and then we'll actually pass it what our test command is. So in this case, we're going to say when we run npm test, run mocha and point it to the test's spec directory. And then again, our command line, we just run npm test, and it goes ahead and takes care of running all of the tests for us. The next step is using your build tool. Right? Your build tool has all these automated processes for compiling JavaScript, compiling CSS, doing things. Use it to run your unit tests as well. So in this case, we're going to use Grunt because all the tests we wrote, or in the previous examples, used Jasmine. And Grunt has the best Jasmine runner out there. But we use Mocha at work, and Gulp has really good Mocha support as well. So, don't tie your build tool to your unit tests. But in this case, Grunt does work better. So here we're just going to install the Grunt command line, install Grunt. And again, I'm not going to get into too much detail about Grunt itself. Just know that it's a build tool and you can use it to run unit tests. And then the last line here is the most important. We're going to actually install our Jasmine plugin. So here we're going to say npm install grunt contrib Jasmine. So now we have a Jasmine task runner in Grunt. So once we have our Jasmine task runner, we're going to modify our gruntfile.js to include our Jasmine task. So here we're going to say, give us a task named Jasmine. We're going to pass it the source file to our tests. And then inside of our options, we're going to pass it this path to our spec files itself. So here we're going to say we need jQuery as a dependency on our tests. And we also have to-do is better that we're going to test. And then our test actually lives in test spec, to-do spec. And to make this automated, we're also going to include a watch task. So we actually would install the watch plugin as well. And then we're just going to say watch all of our source files. And whenever one changes, just go ahead and automatically run the Jasmine test. This way you can write your code and never have to look, switch. It'll actually run automatically, and you'll get a little error in the console if your tests start to fail. So in this case, all we have to do is run our grunt Jasmine command, and it'll go ahead and run all of our unit tests. Again, I'm just going to skip the demo because I don't want another crash. But it does run your tests. It gives you a nice looking output. And in this case, we could also run grunt watch to have it keep watching those files and rerunning Jasmine. There's also a lot of really good tools out there in NPM dedicated just to running your unit tests. So one I like to use is called Testim. But there's another really popular one called Karma that does a lot of the same things. It's used by the Angular guys, so it's very, very heavily used. But Testim does what I needed to do, so I haven't made a switch. So installing it is simple. You install it as a global dependency in NPM, so npm install Testim. And then we have to create this testim.json file. So here we're just going to pass it all of our source files. So we'll pass it jQuery, we'll pass it our to-dos file, and we're actually going to pass it our spec as well. And Testim's smart enough to know which one of these is source files, which one are spec files. And the second key here, launch and dev, this is really neat because you can tell Testim to launch all these browsers and run your tests in them as well. So here we're going to actually launch phantom.js, we'll launch Chrome, and we'll launch Firefox when we run this Testim command. And then we can specify a framework, so it's configurable. We can use Jasmine 1, Jasmine 2, Mocha, QUnit, anything we want, as long as we pass it in that option in the testing framework. And to run Testim, we just run the Testim command. And since this is the last demo, I will risk actually running this. Because if it crashes now, I will just say thank you and all right. Bump up the font. We run the Testim command. So we're actually going to go ahead and open up those test runners. So you see that we have Phantom.js here, Chrome, Safari, and Firefox. If I go ahead and slide these over, you see all these browsers actually opened up and ran the tests in the browsers themselves. So it's a really nice way to automate your tests. It'll also listen for your tests. So if a test changes and a source file changes, it'll automatically rerun all these tests in all of these browsers. So it really takes away a lot of the pain of doing cross-browser testing, and it does it all for you automatically. Unfortunately, I don't think it works with IE. That you're still going to have to do manually. But no one tests an IE anyway anymore. Just forget all about it, right? All right, so that's all I have. Does anyone have any questions? Yes?
If you want to write a class with private functions, that's
Yep.
testable, right?
So the question is, what if you want to write a test with private functions? And no, because you really can rely on the private functions because they are internal, they're not exposed, so they're not going to be mutatable by outside factors. So it's okay to rely on a private function and not have to mock that. But I do believe Douglas Crockford did write something to allow you to test private functions as well. So if you use like the revealing module pattern or something, there is a way to actually make that testable. But typically you don't really worry about mocking or stubbing out private internal functions. Yes?
So what if you want to basically try to test that sort of higher level of abstraction, like basically testing the entire user flow through the bot?
Yep. So that's more of an integration test. So you would use something like Selenium or an automated runner that'll actually handle clicks on a browser interface. So unit testing is just very granular. You're only testing small individual functions. Anything else? Yes?
So with Mocha, I've used Mocha on the server side to do a lot of more testing, but
Yep.
using the terms and trying to configure it for the client side, but my script don't use required. Is there a way to use them? Without requiring?
So your question is you're using requires, so you're using CommonJS type syntax, right? There's no really good way to do that I know of. You can use a transpiler or something. And actually, now I think about spec actually will go ahead and grab those requires and mock them for you. So if you use, Jest. If you use Jest, you can actually test your CommonJS right in the browser without having to transpile or do anything like that. So it might be something you want to look into. Yes?
So I have a question, so sorry to run over everything.
Okay.
You said there's really no level between everything and use Selenium.
Not sure I understand. So
So like, I'm used to like there being sort of a, Selenium is very slow evolving and it's useful.
Yep. Yep.
But I'm used to an integration test level that's somewhere in between the two, where it's still running code, you're running more rendering, and you're not walking everything. So I guess I'm used to a third level kind of in there.
Yeah.
Being very fast and very slow.
Okay. Right. Right.
Anyway, so I'm just wondering if in reality and practice you do have.
That is not something I've ever had to do. So I don't actually know if there's a space in between, but maybe there is. I honestly don't know. All right. Any other questions? No? All right. Great. Well, thank you.